Welcome students. In today's session, we will go through one more example for the problem based upon the greedy method, minimum cost spanning tree. Before we actually understand what a minimum cost spanning tree, we need to know few terms related to the graphs and trees. Okay. Now, we know that graphs means it consists of certain vertices and those vertices would be connected through the edges. Let us consider one particular graph. Let's say there is one vertex A, vertex B, C, and D. Now, so these four are the vertices. These vertices are connected through the edges. Let us say a edge between A and B. In the same way, let us connect all these vertices through the edges. Okay, now the vertex A and vertex B both are connected. There is no direction here. Undirected means no direction, or an undirected graph means now if you consider two vertex A and B, there is no direction. Direction in the sense there is no arrow mark from A to B. There is no arrow mark, right? That means this is an undirected graph. Okay, means from A to B also we can travel, and from B to A also we can travel. Okay, now the graph means here a set of vertices, and those vertices are connected through the edges. Okay, that is the first one. Let us consider, let us say that this is a graph denoted by G by certain vertices and a certain edges E. So G of VE means a graph containing a certain number of vertices and the edges. Okay, now, so in this particular example, the number of vertices are equal to 4 and number of edges are equal to, again, that is also 4 here. Okay, now, secondly, the second concept is something called as a tree. Again, tree consists of certain vertices, and those vertices are definitely connected through the edges. Now here we're trying to understand something called as a spanning tree. A tree can be said as a spanning tree if and only if, pay attention students, a tree can be called as a spanning tree if and only if there exist V dash and E dash as the number of vertices and number of edges, such that the V dash is equals to V and E dash is equals to V minus 1. We can, from any particular graph, we can derive a spanning tree. So what is the definition of a spanning tree? The definition of spanning tree is nothing but a tree consists of a certain number of vertices and a certain number of edges. Now here they are denoted as V dash and E dash, right? Now this V dash is nothing but it is equal to P itself, that is the total number of vertices in a given particular graph. But the number of edges, that is E dash, is equal to total number of vertices in the graph minus 1, that is 1 less than the total number of vertices. Suppose if we want to derive a particular spanning tree from this particular graph, then that spanning tree will contain 4 vertices and the number of edges will be 3, that is 1 less than the particular number of vertices. Now that means here I can have different possibilities, like say 4 vertices, that is A, B, C, and D. Correct? Now, if I want to construct a spanning tree from this particular graph, that spanning tree will definitely have the same number of vertices as of this particular graph. So I have 4 different vertices here, but The number of edges over here can have at the most, or the number of edges will be equal to 3 here. That means I can have something like this as a first edge, which is connected between A and C, a second one connected between C and D, a third one can say between B and D. Now, here there are 3 different edges and 4 vertices. Then this I can call it to be a spanning tree. I can call this particular tree to be a spanning tree. Now, suppose if this particular graph can have certain weights. Weights in the sense certain value associated with a particular edge between the vertex, between 2 vertices. Consider that between this particular A and B, the cost is, let us say, it is 5. Then between A and C, consider it to be a 7. Between C and D, the edge cost is 10, and B and D, it is 2. Try to think in this way, like there are 2 different places, that is A and B. Okay, now in order to travel between A and B, you require 5 rupees, right? If you want to go through any particular travel mode, you require a 5 rupees, or even you can consider it to be a what? It is distance between this A and B to be a 5 kilometers. Any particular weights or any particular units you can try to assume it. Assume here, right? So if a graph is having certain weights, that is if edges are having certain weights, then such graph we call it to be a weighted graph. We call it to be a weighted graph, wherein every edge will have certain weights. Okay, now if I construct a particular, or if I derive a particular spanning tree from a given weighted graph, then this particular spanning tree will also have certain weights. For in this example, for this spanning tree, these are the weights, right? 7, 10, and 2. What is the total cost of this particular spanning tree? It is nothing but sum of all the edges, that is weights of all the edges. So here it turns out to be a 10 plus 7 plus 2, that is nothing but total cost as 19. Total cost as 19 units. Okay, now if you observe here, this is one among the many spanning tree that we can derive from a given graph. That means if there is a graph, we can construct or we can derive multiple spanning trees, and this is one among them. If you notice here, the vertices A and B are not connected, right? I can have a one more spanning tree from this particular graph as this. Let us say A, B, C, and D, right? Now, in this case, what I would do is that I would connect AC, AB, and AD. Now, is it a spanning tree? Yes, obviously it is a spanning tree. How? The number of vertices here are same as the number of vertices in the given graph, and the number of edges are less than total number of the vertices, right? So this is also a spanning tree. What is the cost of this particular spanning tree? Is nothing but the sum of the cost of the individual edges, that is 7 plus 5 plus 2. So if we add the cost edges, it turns out to be 7 plus 5 plus 2 as 14. So the 14 is the total cost here. Now, when I derived one particular spanning tree, the cost is coming as 19. When I derive the other one, the cost is coming as 14. Now, think a while and see whether are these only the two the spanning trees that we can derive from this particular graph, or can we have few more spanning trees? Yes, we do. We can have, or we can construct few more spanning trees here, right? Now, let us try to construct the few more spanning trees from that particular graph A, B, C, and D. This time I will connect AB, AC, and CD. So the cost would be here 5, 7, and 10. So total cost is here it is going to be 22. And the one more spanning tree that we can derive or construct here, A, B, C, and D. So I can construct in this way. This is also another spanning tree, and the costs are 5, 2, and 10. So it comes to be 17 here. Now, if you look at here, from a given graph, we can derive here total 4 different spanning trees, right? And if you look at the costs of these spanning trees are 19, 14, and 22, and 17. Now, the problem here is that we need to find out a spanning tree whose cost is minimum, right? As we are trying to study or understand the greedy method means there will be multiple solutions, right? So all these are what? The multiple solutions, that is feasible solutions. There is a constraint. Constraint is what here? The spanning tree, right? There is a graph and we have a particular spanning tree from that. We need to design a spanning tree, means number of edges should be less than the total number of vertices, right? That is the constraint what we have. Then we need to have our function, that is either we need to optimize our objective function, either maximize or minimize. Since it is a spanning tree and the spanning trees will be having the weights, that is the cost, we need to try to have a minimum cost for the spanning tree. So we have total 4 solutions, 4 feasible solutions, right? Among these particular 4 feasible solutions, we need to derive a optimal solution that will have a minimum cost. I can say that out of these particular 4, I can consider this particular spanning tree as a minimum cost spanning tree, because the cost of this spanning tree is 14, which is the minimum among all these 4 values, right? I hope the concept of a graph, what a minimum spanning or the spanning tree, the concept of a spanning tree and the minimum cost is understood here, right? Now, we are going to discuss 2 different approaches or the methods which will help us in calculating the minimum cost a spanning tree for any given graph. The 2 methods are going to be, first one is Prim's method, second is Kruskal's method. Okay. Let us try to understand what these particular Prim's method and Kruskal's method are. The first one, we call it as Prim's method. So Prims has designed a particular algorithm based upon the greedy method. The approach is going to be based upon greedy method, right? There will be a multiple solutions. Out of those multiple solutions, we need to choose only one, right? As we know that greedy method, at every stage, we try to become greedy, which one to select. If we go in one particular direction, that should be either maximizes or minimizes our optimal solutions, right? Now, let us understand this particular Prim's method in order to calculate the minimum cost spanning tree by considering a simple example. Okay, let us have one particular graph containing certain vertices. Let us say 1, 2, 3, 4, 5, 6, and one more 7. So there are total 7 vertices. All these 7 vertices are connected through the edges like this. Okay, all these edges have their own weights. Let us try to write the weights of those particular edges. Between 1 and 2, it is 28, 10, 25, 22, 24. This is 14, 15, 12, and 16. Now, this is a graph. We can say more properly as a weighted graph because the every edges have certain weights involved in that. Now, the task here is to find out the minimum cost spanning tree. So we can have a spanning tree out of this. That particular spanning tree should definitely have the same number of vertices as this graph, that is 7 vertices, and the edges should be only 6. Okay, the number of edges in that particular tree should be 6. Such a way that the constraint is that the cost should be minimum. The cost should be minimum. Okay, now let us try to sort it out or calculate using the Prim's method step by step. Let me keep this particular diagram or a graph one side and let me try to calculate the solution on another sheet. Okay. Okay. Step 1. We have here total 7 vertices. We can start from any one of the vertex. Let us choose the vertex number 1 itself. Suppose in your examination, if you get an different vertices like 1, 2, 3, 4 or A, B, C, D, it's better that you start with the vertex A or vertex labeled as 1. Okay. Now, the step 1 is that I can start from vertex 1. From vertex 1, I can either go towards 6 or I can either go towards 2. Right? There are 2 possibilities. That means from vertex 1, I can reach vertex 2 or I can reach vertex 6. Right? Now, the point here we need to consider that which particular direction we should go. That will be depending upon the greedy method. So what greedy method says, between vertex 1 and 6 I can travel, and from 1 I can travel to the vertex 2 also. What is the cost involved between the vertex 1 and 6? It is 10. Between 1 and 6 it is 10, and between vertex 1 and 2 the cost is 28. Now objective function is what? We need to have minimum cost. Minimum cost means I will choose definitely traveling from 1 to 6. That means from 1 to the vertex 6 I will reach out with the cost of 10 so that I can minimize my cost. Okay, this is step number 1. Now, in the next phase, step number 2, what I need to do here, I need to check out from now. If you look at here in the next step, I can either travel from 1 to again 2. Now I have traveled between these 2. Now I have 2 possibilities, that from 1 I can move towards 2 or from 6 I can move towards 5. Right? Look at here once again. I have constructed an edge between 1 and 6. Now I have got 2 possibilities, that from 1 also I can move forward or from 6 also I can move forward. Right? Now, let us try to write that particular thing over here. Let me try to reposition the papers properly, students. Give me a moment. step 2. So in step 2, already the step 1 part I have taken care. So I need to draw this one, 1 2 6 connected between these two with the cost of 10. Now from 1, now in the second step, I have two possibilities, right? Either I can travel from 1 to 2 or 6 to 5. So let us write the edges here. From 1 to 2, the cost is going to be 28. And from 6 to 5, the cost is going to be 25. Right? Now, definitely, I will be choosing the vertex, the 6 and 5 here because the cost is less. It is lesser than the cost of 1 and 2. So here from 6 to 5, I will travel with the cost of 25. So this is step 2. Now, if you carefully look here, at every stage or every step, we are trying to think as a greedy. We want to reduce the total cost. Right? This is step number 2 here. Now, the next step, step number 3, let us rewrite whatever we have as part of the step 1. This vertex 1, vertex 6, vertex 5. The cost between these edges has 10 and 25. Right? Now, from this particular graph and the what tree we have derived as of now, you can try to see here from 1 to 2 I can travel and the cost is going to be 28. Then from 6 to 7 I can travel. Sorry, from 5 to 7 I can travel and the cost is going to be 24. And from 5 to 4 also I can have, that is 5 to 4 with the cost of 22. Now, in this stage, if you look at the construction of or deriving the spanning tree, I have got 3 different possibilities. Right? The first one is I can either travel from 1 to 2 with 28 cost, 5 to 7 with 24 cost, and 5 to 4 with 22 as the cost. Now, definitely, I'm going to choose 5 to 4 because it is going to give me a less or the minimum cost. So from 4, I can travel to 5 with the cost 22. Okay, now move to this next number, that is step 4. In the step 4, let us rewrite whatever we have derived so far. So here I will get 1, 6, 5, 4 connected like this. The cost 10, 25, and 22. Now, from this particular graph, what I can say, from 1 to 2, I have a possibility with 28. From then, next possibility is from 5 to 7, and the edge cost is 24. See, from 5 to 7 also I can go. Then where else I can go? From 4. From 4, I can reach to 7. That is 4, 7, and the cost is 15. Then I have one more possibility, that is from 4 to 3 also I can travel. That is 4 to 3. And what is the cost involved in that? It is 12. Now I have 4 different options, and the minimum here again is this particular 12. That is from 4 I can reach to edge or the vertex 3, which costs me only 12. Right? Now, if you count the total number of edges here, we have 1, 2, 3, 4. Is it a spanning tree? No, it is not at a spanning tree because we need to have 6 edges and we need to cover all the vertices. Right? Still, we have left out with 2 more vertices. Okay. Now let us continue with the next step. The next step, let us write whatever we have derived so far at the step number, I think it is 5, step 5. So far we have covered from 1 to 6, from 6 to 5, from 5 to 4, and from 4 to 3, with the costs 10, 25, 22, and 12. Now, here, what are the possibilities I have got here? The possibilities are, again, from 1 to 2, I can go, which will cost me 28 from 1 to 2. Then from 5 to 7, this particular 5 to 7 will cost me again 24. Then from 4 to 7 also I can travel. 4 to 7 if I travel, then the cost is going to be 15, right? And then I have from 3 to 2, that will cost me 16. Okay. Now, here we have got 4 different possibilities. From out of these 4, the minimum cost is what? This one, that is 50. That is from 4 to 7, I can reach. So now here, the vertex 7, and between 4 and 7 is going to be 15. Okay. Now, the next step, step 6, let us rewrite whatever we have earlier. That is 1, 6, 5, 4, 7, and 3. And the connected edges are like this: 10, 25, 22, 12, and 15. Okay. Now, again, here possibilities are from 1 to 2, I can go, and the cost is 28. From 5 to 7, see, from 5 to 7, I cannot go, because if I go, it makes a loop here. If it makes a loop, then I cannot construct a spanning tree. Remember that in a spanning tree, there will never be any loops between the vertices. So 5 to 7 is excluded. It is not at all possible, right? Then what are the other options I have got? From 3, I can move on towards 2, right? So 3 to 2, the cost is 16. Then the left out one more is from 7 to 2. So from 7 to 2, I can go. From 7 to 2, if I go, the cost is going to be 14, right? So these are the 3 possibilities I have got here. From 1 to towards 2, I can go, right? Second is from 3 towards 2, I can go, right? Or from 7, I can go towards 2. And the respective costs are written in this way. Okay. Between this 5 and 7, from 5 to, that is from 7 to 5, I cannot go, or from 5 to 7 also I cannot go, because it will construct a loop over here. So loops are not possible in spanning. Among these different possibilities, I can choose this one, that is from 7 to 2. So this cost, that is 40. Right? So now, is it a spanning tree? Count the number of edges: 1, 2, 3, 4, 5, 6. Right? Are they one less than total number of vertices? Yes. That means we have reached or we have constructed a spanning tree which cost minimum. So the cost of this particular minimum or cost of this particular spanning tree is nothing but cost of spanning tree is equals to 10 plus 25 plus 22 plus 12 plus 15 plus 14. Okay. Now, if we add all these, we get the total cost of this particular spanning tree. So the total sum is going to be here 10, 25, 35, 22, 12, 15, 14. So I think it will come around 98. That is the minimum cost. That is minimum cost of the given spanning tree. So to just summarize, students, the Prim's method, how it works in order to calculate the minimum cost spanning tree, we need to start from any of the vertex. It need not to be that we need to start from the vertex 1. We can start from any of the vertex, but it is good that we start from the first labeled vertex. So if it is a 1, 2, 3, 4, you can start from 1. If it is A, B, C, D, then you can start from A. From one vertex we started, from the vertex 1 we started, then we looked into the different possibilities where we can reach to any particular vertex. Then we counted the cost involved in that particular edge. We then choose the one which costs less or which cost minimum. That means from 1 to 6 we traveled. Then after that we can have between 1 to 2, or we can even go from 6 to 5. But among these two, 25 and 28, the minimum is 25. So we went forward in this particular direction. And then from here, we have got three possibilities. That is, from 1 to 2, we can go, from 5 to 7, and from 5 to 4 also. But the cost involved among them, the minimum cost is 22. So we went in this particular direction with 22. Let me give a tick mark how we traveled. Again, from 22, once we reached the vertex 4, we have got the different options. That is 1 to 2, we can have, from 5 to 7, we can have, from 4 to 3, we can have, or we can have from 4 to 7 also. And the cost, the minimum cost was this one. So then we went ahead with 4 to 3. Now, after we reached 3, we have got few more options, from 1 to 2, 3 to 2, then 4 to 7, or 7. From among this one, the minimum cost was this one, so we choose in this way. And then finally from 7 to 2. Remember that while constructing a spanning tree, if any edge, while connecting any particular vertex through the edge, if it makes a loop, then it will definitely not give us a spanning tree. So the loops have to be avoided at the time of creating or deriving the spanning trees. And then we calculated the total cost involved in that gave us the minimum cost. I hope the concept is understood, students. The graph, or what a spanning tree is, and how we can calculate the minimum cost spanning tree for the by using the Prim's method. So based upon the exercise which we have carried out now, you can try to solve a couple of examples. Take this as a one example. The first assignment, the weighted graph is given. From this particular weighted graph, try to calculate or try to find out the minimum cost spanning tree. Okay. The second one, you can work it out for this. Okay. So in this is a little complicated one. So if you can solve this exercise, then you can I can say you have masterized the Prim's method. Now for in this case, you can find here certain weights having certain edges are having same weights. At the time of calculating or deriving the spanning tree, if you come across a situation when there will be two different possibilities or two edges you can travel through, and both of them are having same cost, then you can choose any one of them. There is no hard and strict rule that you need to choose only one of that. You can choose any one of them, and you need to ensure that that doesn't make through the, or that doesn't make any loops out of that. Okay, so solve this as a second exercise. So this will complete your greedy method on the Prim's examples or the Prim's method. In the next class, we will go through the next one, that is Kruskal's method of calculating minimum cost spanning tree.